help with the ratios in the media. Hold on, let me get my paper set up here. So we talked about aspect ratios in the media. One of the things that we had to do was find the width and the height of a TV screen when we're given the diagonal dimension, right? So when they say a 25-inch TV or 72-inch TV, they're always talking about from corner to corner on the diagonal side. That's what they call the size of the TV. With the aspect ratios, right, it's always width to height that will be given to you on your formula chart. So I need to use my aspect ratio and figure that out. So there's two ways I can go about doing that, and I will show you both. So first one is algebraically. So if you prefer this method, right, so we know that it's going to be a 4:3 ratio. Okay, so 4 times something to the width and 3 times something towards the height, right? These things are going to be multiplied by the exact same scalar value, whatever that scalar value is. Okay, so it's going to be multiplied by some number. So to show that, for this, we know it's going to be 4 times some number, and this one's going to be 3 times some number. Okay, because if I were to reduce that, I would still end up at a 4/3 ratio. So for those of you who like to see the math of it, if I were to take the width over the height, whatever that x value is, doesn't really matter, because either way it's going to be the same and it will cancel. So I will still get a 4:3 ratio, which is what I'm trying to get. So I'm going to use 4x and 3x to represent my width and my height. And then from there, right, I'm going to use Pythagorean theorem. Pythagorean theorem will also be given to you. So here we go. So I'm going to take this, and I'm going to go 3x squared plus 4x squared, which is equal to c squared. Well, c is the diagonal, which is the value that they give me. So 25 squared. And I put that in the wrong spot, so let me fix that. So that squared should be outside, because it's the entire thing squared. So 3x, right, because it's this squared plus this squared equals 25 squared. So now from there, right, it's just a matter of using your algebra skills. So 3x times 3x makes 9x squared. Make sure you square both the number and the variable. So on the quiz, a lot of people left off those x's, and you have to have the x's there, because that's what we're trying to figure out is the x value. So 9x squared plus 4x times 4x makes 16x squared, and then 25 by 25 makes 625. Okay, so then from there, combine like terms. Those are both x squared. So 9 plus 16 makes 25x squared, which is equal to 625. Okay, divide that 25, divide by 25, and x squared is equal to 25. Okay, notice that is x squared is 25. Here, the 25's cancel. Okay, so then x squared is 25, so x square root both sides, and we get x is equal to 5. Technically plus or minus if you're talking algebraically correct, but since we're talking about a scale factor, we can't scale factor a negative, because that would give me a negative length, and that doesn't make sense. So we're only going to look at the positive. Okay, so x is equal to 5. This number right here is our multiplier. Okay, this is the factor that we're going to multiply everything by. So we're blowing everything up by 5. So we have to take and plug this back in, right? Because we said that this was 3 times x, this was 4 times x. Well, we now know what x is, so that means this is 3 times 5, which is 15. So that makes my height is 15. Okay, and this is in inches, so we've got our height is 15 inches. And then 4 times 5 is 20, so that's going to be my width. So the width is 20 inches. Okay, so simple as that. And then find the area of the screen. You just multiply 20 times 15. Okay, so 20 times 15, which would be 300. Now be careful with your units. This is now inches squared, because this was an inch times an inch, right? Inch times inch makes inches squared. So make sure you put the proper units. Okay, so we get 300 inches squared. Okay, so I'm going to show you the other way of doing this, and then we'll look at the percent part. So find the height and the width of a newer 48-inch television whose screen has an aspect ratio of 16 to 9. Okay, so 48-inch TV, 16 to 9. So the other way to do it is to set up a proportion, which is what most of the unit has been about, right? So we've been doing a lot of proportions. Okay, so basically we're going to set up similar triangles. So we're going to make this a small little TV, and this is going to be the big TV, and since it's supposed to be proportionate, right, because it's supposed to have the same aspect ratio, then we can set up a proportion. So we got our little tiny TV, and we just make these the dimensions. So this thing is going to be 16 in width by 9 in height. Okay, and then that makes the diagonal something we don't know. Okay, but then we've also got our big TV, and we don't know these. We don't know the width, we don't know the height, but what I do know is that this is 48. Okay, because this is a 48-inch TV. So then we can set up proportions, because if the aspect ratios are the same, they should be proportionate. So if I do, let's just say we go, and it doesn't really matter as long as you stay consistent. So let's say I go the width of the small TV over the diagonal of the small TV. That would have to be the width of the big TV over the diagonal of the big TV. Again, there's lots of ways I can set this up. It doesn't matter. I could have gone 16 over W and C over 48. What's important is that you stay consistent. So like here, I have the widths going across the top, and I have the diagonals going across the bottom. And this first one is all small TV, and the second one is all large TV. Okay, so what matters is that you stay consistent with it. So we could have done diagonals on top and widths on bottom. Okay, we could have done larges on the left and smalls on the right. Okay, we could have even switched it up differently, right? So the important part is that we stay consistent. So you can't do like width on top and then on the second one have your diagonal on top. That doesn't work. Okay, so make sure you stay consistent with it. Okay, so then from there, cross multiply. Okay, so I've got I messed up. So I've got to figure out what my C value is, right? Because I've got two variables here, so we can't do this with two variables. So first I need to figure out C, right? But I've got Pythagorean theorem to help me do that, because I've already got both sides, right? Because if this is 9, it's a box, so this is also 9. So we can Pythagorean theorem this to figure out what C is. So let's find C first, so then we can solve this. Okay? So I've got 9 squared plus 16 squared equals C squared. Okay, which would be 81 plus something that I need a calculator for. Right, so 256 equals C squared. Add those together, and you get 337 is C squared. Square root. So C is equal to approximately, we're going to have to round, so I'm going to change that, 18.358. Right, rounding to 3 decimals, because anytime we have to round, that's what we're going to do, unless it says otherwise. Looking at the calculator, right, so go to my third decimal, look at the fourth. If it's 5 or higher, then you round that third number up. So 18.3575 becomes 358, right? So that's how you round properly. Okay, so there is my C value. All right, so now we can go back over here and replace that C value to 18.358, which now makes a whole lot more sense, because now I only have one variable in the way. Right, so now I've only got one variable. So now we can cross multiply and solve for W. Okay, so now cross multiplying. So I've got right here 18.358 times W, so 18.358 W. And then 48 times 16, which is 768. Divide that out, 18.358 gives me W is equal to 41.835. Alright, again, rounding 41.8346, so 46 becomes a 5. Okay, so there's my width, so I've got 1. So second option, so here I can either Pythagorean theorem to figure out h with my new W and my hypotenuse. So that is one way to do it, or we can set up another proportion. It's totally up to you how you do it. I'm going to just set up another proportion just because I can. Alright, so you can kind of see the other ones. So I'll set it up a little differently just so you can see you get the same thing either way. So Again, I want to do the height now because I already got my width, so that means I'm going to use the height of the small triangle. I know my diagonal, and I'm going to use my diagonal there. So I could do it totally different. I can go the height over the height. So let's say I go height 9 over the height of the big one. Okay, 9 over h. So then that would make this the small. Right? And this would make this the large. And then these are both the height. So then these will both be diagonal. So when I set up my second fraction, I have to make sure that I go with the small diagonal on top, which was C, which was our 18.358. So 18.358 over, and then our large TV, which our diagonal was 48. Okay, so again, just staying consistent. Here I did small and large on top. Here I did it on sides. It doesn't make any difference at all as long as you stay consistent. Those are both small measurements. Those are both larger measurements. Those are both height measurements. Those are both diagonal measurements. So as long as you stay consistent, that's what's important. And then we cross multiply. All right, so cross multiplying, I've got 18.358h equal to 9 times 48, which is 432. Divide that number over. 18.358, and h is equal to 18. Oops, hit the wrong button. H is approximately 23.532. Okay, 23.532. Okay, and you can always go back and check your final answer. So when we divide this out, it should be the same as our 16 to 9. Okay, so when you divide that out, it should be approximately the same. Now, it might be a little off because we had to round these numbers. But if I do 41.835 divided by 23.532, right, I get 1.77777, right? So when I do 16 over 9, you should get approximately the same number, okay, because the ratios should be the same, which mine are. So that's a good way to go back and kind of double check to make sure your answers. All right, I did my width over my height, and I did my ratio over my ratio, my width ratio over my height ratio, and I get approximately the same thing. Again, my numbers later on are off, but that's because I rounded, so the numbers aren't going to be perfect because I rounded, but I mean, we're perfect all the way out to the 4th decimal, so that's pretty good. Okay? So that's how you do just finding the height and width. That's the two different methods. Pick the one you like. It doesn't really matter. So this is where most people struggled on the quiz, so we'll talk about that. So we'll just look at this one. So figure 2 shows actually, let's look at the first one. So figure 1 shows a letterbox image. So letterbox just means that we're filling the whole width, right? But we have these black marks on top and bottom because we're not filling the entire vertical component of our TV. So we have an aspect ratio on our image of 16 to 9, right? And then I've got a screen with an aspect ratio of 4 to 3. Okay? So we've got image 16 to 9, screen 4 to 3. Okay? So our ratios aren't the same, which means that there's no way to blow this up. Okay? Well, there might be, but we're not sure whether or not we can blow these things up so that it fits perfectly. Now, a lot of people just immediately try to do like times 4 and times 3. But remember, when we blow things up, it has to be multiplied by the same on both. So it says letterbox. So that letterbox tells us that it's going to fill the entire horizontal component. So we don't really care what size the TV actually is. We can just use the aspect ratios to help us figure out what percentage we're going to use. Because it doesn't matter whether these TVs are big or little. Since it's percentages of aspect ratios, it's not going to make a difference. So what I like to do is just make whichever one is bigger, go ahead and make that dimensions. Right? So I'm going to say that my image is 16 inches by 9 inches. Okay, because I just used the aspect ratio and I just changed it into dimensions because it doesn't matter what size the image or the TV is. Now, I want to expand my screen, so I need to blow this up so that it fits around my image. So it needs to fit around a 16 by 9 image. Well, what do I multiply it by to get it there? So to figure that out, since I want to expand to the width, I'm going to use the width, right, because aspect ratios are written width and then height. So I'm going to use the width value, and I'm going to divide it out. So this is the width, the 16, and the 4. So I'm going to divide that out. What that's going to do is give me my multiplier. Okay, so this is what I am going to multiply by. This is my scale factor, if you want a better word, right? So it's a scale factor. So we're going to basically magnify this thing by 4 to fit around this image. Okay, so to figure out what the dimensions of my screen are going to be, I just use my new multiplier, and I multiply my ratio of my aspect ratio. So my screen's aspect ratio is 4:3. So I'm going to multiply both of those by 4 and get 16:12, and those are going to be my new screen dimensions, 16:12. Okay, so here, when you look at the numbers, the entire width is being filled. They're exactly the same, so the whole screen is being filled with the entire image, right, 16 and 16. Okay, but here, I'm not using the entire height. I'm only using 9 out of the total 12 inches. So then, the very last part is what percent of the screen's area is occupied by the image. Okay, well, we're talking about area and percentages. So to figure that out, we just find the area of each, right, length or width times height, and divide width times height. Okay, you're always going to be dividing the smaller one by the larger one. Okay, because if not, then that would mean that you're using more than 100%, and that doesn't make any sense, right? So 16 by 9. Okay, so we've got 16 times 9. And really, if you know your math skills here, you can just cancel out the 16s, but I'll do the full area just so you can kind of see. All right, so 144 is the area of the image, and then 16 times 12 is 192, which is the area of our new screen, right, because we made these into actual dimensions. And so 144 out of 192 would be 75%. You actually get 0.75, but don't forget to convert that. This is not a percentage. All right, that's a decimal, so then times 100 gives you your percent. So 75%. Okay, so that's how you find the area. All right, so I'll go through that one more time just real quick so you can kind of see. So pillar box, we're going to stretch to fit the vertical. That's this. So this time the vertical is going to match up instead of the width. So I'm going to do the exact same thing, but I'm going to stretch it to the vertical. So pillar box, I've got a 4:3 image, and I've got a 16:9 screen. So this time my screen is the bigger one, so I'm going to blow my image up to match my screen instead of stretching my screen to fit it, because again, the dimensions don't matter as long as the ratio stays the same. So I've got a 16 by 9 screen. Okay, so I want to make the heights match. So to figure out how to make the heights match, you divide. So 9 divided by 3, which would give me 3, so that's going to be my multiplier. So I'm going to multiply my image, right? So I'm going to take my 4:3, multiply each of them by 3. It is important that you multiply both, because remember, to keep the ratio, you have to multiply both of them by the same number, right? So 4 times 3 makes 12, and 3 times 3 makes 9. So again, we've got our, hold on, let me write image. Right, so I've got that my vertical components are the same in both. So when you look at the TV, the whole image and the TV are going to be the same. So we're going to use that whole vertical space, but our widths are going to be different because we're going to have this leftover space on both sides of our image. Okay, so 16 by 9 is the screen, 12 by 9 is the image, right? We're going to do the smaller over the larger, which should always be image over screen, right? Because your image should always be smaller than your screen, because otherwise you can't actually see it all. So 12 by 9 divided by 16 by 9. Again, if you are good with your fractions, right, you can actually cancel 9s and go from there. But if you're not, then just find the whole area. 12 times 9 would give me 108 on top. So that's the area that the image is using. And then 16 by 9 is the area that the TV is, that makes up the TV. And when you divide that out, you get 0.75, which gives me 75%. Now, please keep in mind that the answer is not always 75%. I know a lot of people on the quiz, you guys just wrote 75% because it happened to be the same answer on this. They were trying to show you that if the aspect ratios are the same, it doesn't really matter. Whether it's the image or the screen, you end up with the same percentage is what they were aiming to kind of show you. But you can have different aspect ratios for both the image and the screen, so it won't always be 75%. So don't just write 75%. Okay, so that's all you really need to know. That's the main part of the ratios in the media worksheet that you need.